All right, this morning we are going to work on some more interior-exterior angles of polygons. So just a little review at the top. I have a polygon, this is a pentagon, and if you guys remember from yesterday, if you want to find the interior angles of a polygon, to find that sum, all you have to do is 180 times the number of sides minus 2. So we have, in this problem, a pentagon. So I would do 180, number of sides would be 5 minus 2, so we're going to do 180 times 3, which is 540. All right, so there's just kind of my work there to the side to determine what the inside angles should add up to. Now, only other thing I want to add to this picture real quick is just a reminder where angle A is at, that's going to be 90 degrees. Okay, so here's all I'm going to do. We're just going to set up an equation to solve for x. These two angles are marked as congruent, so I actually have two angles with a measure of x. And then just go through here and add these other angles. So I've got 100 plus 70 would be 170, plus 90 is going to be 260. Okay, going to set that equal to 540 since we're working with the pentagon. Going to subtract 260 from both sides. I'm going to get 2x is equal to 280. And then if we divide both sides by 2 here, that x is going to represent a 140 degree angle for that first question. Now, we're going to do a lot of focus today on regular polygons. I mentioned this yesterday, but we didn't really do a lot of problems with this. So regular polygon means all sides are congruent. So if I had a pentagon, for example, this is not a regular pentagon, all 5 sides would be the same length, and all angles are also congruent. So if I had a pentagon, and I was talking about a regular pentagon, all 5 of the angles would be the exact same measure. And we're actually going to deal with that in our first example down here. Pause this at any time if I'm going too fast. Now, we just figured out the sum of the inside angles of a pentagon was supposed to be 540. This says find the measure of one interior angle of a regular polygon. We're talking about a pentagon here. So if I have a pentagon, I have 5 interior angles. So I take that interior angle sum and divide it by how many angles there would be, which is just going to match the number of sides, which is 5. And if you go ahead and divide that, you're going to get 108. So each of the 5 angles inside a pentagon that's regular would be 108. Now, quadrilateral, if you don't know this, that's okay. It's 180 times the number of sides minus 2 to get the interior angle sum for any polygon. So quadrilateral has 4 sides. So this would be 180 times 2, which is going to give us 360. Okay, now 360 is the sum of all 4 angles. We just want one of them. If it's regular, they all have to be the same. So I'm going to divide that evenly by that 4. And so this is going to end up being 90 degrees. And regular quadrilateral has a special name, and hopefully you guys know that. It's going to be a square. All right, and you guys forgive me on this one. I'm actually going to cross out letter C because that is not a possible interior angle of a regular polygon. So we're just going to focus on D. This question's a little bit trickier than what we just did because it's going to work backwards. So we're not doing this one though. I'm giving you the measure, this 144 here is what we're going to use, of one interior angle of a regular polygon, and we want to determine the name of the polygon. So I have to figure out the number of sides. Okay, so what we did in the last step, we did the sum of the interior angles. So we did the 540 for the pentagon, the 360 for the quadrilateral. I don't know the sum. I know the measure of one angle. So I'm going to set this up using the formula that we used to determine the top of the fraction in the last problem. Now the bottom of the fraction just ended up being the number of sides for both of these, so I'm just going to put n down here. Now we're not crossing anything off, it doesn't work that way, but I know if I take my sum divided by the number of sides, that should be equal to the one angle that we're given here. Now, easiest way I can tell you to do this problem, this would be equal to 144. I am just going to do one quick little thing and set this up as a proportion. I think it'll be easier for people to solve, especially since we got a fraction that has variables in the top and the bottom. So let's just do a quick proportion here. Cross multiply. So the first cross product, I would just have the 144 times n. The other cross product is just going to be 1 times that 180 times n minus 2. Alright, I'm just going to real quick do a distributive property here. 180n minus 360. Now, what I'm going to do, I'm going to subtract 180n from both sides. And our variable is going to be negative, but that's going to be okay. So this is going to be negative 36n is equal to negative 360. Now, when I divide both sides by that negative 36, scooch this up a little bit here, what we're going to end up with is 10. Okay, now if you're solving a problem like this, it should always be a nice number because we're talking about a number of sides, so I can't have a decimal or fraction. And it can't be negative because we can't have a negative number of sides. So this is for a 10-sided figure, which is called a decagon. Alright, the new theorem we're going to work on today is actually just a number. So the interior angle measures of a polygon change, but the exterior angle measures, no matter what the polygon is, will add up to 360 degrees. Now, what you have in each of these pictures next to this are just 3 different polygons, and they're just showing you that when they add the exterior angles together, that every single time 360, 360, 360. So no matter what the shape, if you're working with exterior angles, they will add up to 360 degrees. Alright, so let's flip to the back. Okay, so if I'm talking about an exterior angle, and I'm talking about a regular polygon again, then those have to always be exactly the same. So one exterior angle of a regular polygon, well, exterior angles, no matter the shape, add up to 360. So we're just going to do 360 divided by, put a little formula here, just 360 divided by the number of sides. For quadrilateral, that would be 4. So your exterior angle is 90. An octagon has 8 sides, so I'm going to do 360 divided by 8, and that's going to be 45 degrees. Now, if I give you an exterior angle, and I have the regular polygon we're going to solve, what I'm going to do, I'm going to use this little tiny fraction I wrote here. If I divide 360 by the number of sides, that should be equal to the exterior angle. So what I'm going to do here is just kind of what I did in that problem on the front. I'm just going to make a little proportion by putting 120 over 1. So this would give me 120 times n equals 360. Divide both sides by 120. Number of sides here would be 3, so that's a triangle. Same thing for part D. If I know one exterior angle, I know 360 divided by the number of sides is equal to an exterior angle. Just going to write that over 1. We'll quick cross multiply, and we're going to get 72 times our number of sides equals 360. So we're going to do 360 divided by 72, and number of sides there is going to be 5. So this would be a pentagon's exterior angle measure. And I have 2 problems here. Doesn't matter what the shape is, if we're dealing with exterior angles, they have to add up to 360. So this is a quadrilateral. I have all 4 exterior angles. So I'm going to go ahead and add those up, and it should be equal to 360. So there's 4 x's here, 1 more here, so 5 total. And if I do 162 plus 98, that's 260. Now, all 4 of these exterior angles added up should add up to 360. So I'm just going to solve this equation. We're going to subtract 260 from both sides. And x is going to represent 20 here. Now, the other one is a pentagon. It doesn't, no, I'm sorry, this is actually a hexagon. It doesn't really matter the shape as long as we have all the exterior angles with a label. I'm just going to go around here. We have 1, 2, 3, 4 ends, and then we've got 2 exterior angles that are both marked with that right angle symbol. So this would be 90, this would be 90. So if we add that up, 180. Now, no matter the shape, the exterior angles always add up to 360, so I'm going to set that to 360. If you subtract 180 from both sides, we're going to get 4n is equal to 180, and then if I divide that by 4, n is going to be 45. Alright, and then I have one figure at the bottom here. This is kind of a combination of what we did yesterday and today. So all the interior angles are not labeled and all the exterior angles are not labeled in this diagram. But let's just go through real quick. This is 1, 2, 3, 4, 5. This is a hexagon. So I know the exterior angles, any shape, add up to 360. What I want to do here is find what the inside angles should add up to, just as a little review. So 180 times 6 minus 2, 180 times 4, 720. So the inside of this should add up to 720. The outside exterior angles will always add up to 360. All right, what I want to use right away is, as much as I can, a lot of these angles form straight lines with an angle that's labeled. So in this case, if I start, I'm just going to start at B. If this is 80, this exterior angle, angle B makes a straight line with that, so those two have to add up to 180. So B has to be 100. If 120 is inside, that exterior angle of E right next to it forms a straight line. These have to add up to 180, so that has to be 60. If F is 75, and I'm sorry, the exterior angle to F is 75. If I do 180 minus 75, we're going to get F to be 105 here. I've got an interior angle of 140. G, the exterior angle forming a straight line with that, has to add up to 180, so that has to be 40. And angle A up there, this has got a 134 degree angle, so just going to do 180 minus 134, and that'll be 46. Okay, now you really have two options here. You know all of the angles except for C and D. So I'm missing one interior angle and one exterior angle. So here's what we could do. We could do 720 and subtract all these angles to get C, or I could do 360 and subtract all the exterior angles to get D. It's totally up to you. I'm going to do 360. And I'm going to subtract each exterior angle, the 80, the 46, the 40, the 75, and the 60. And the leftover has to be angle D. So I'll just show you guys that on my screen real quick. So 360, I'm just subtracting each of the exterior angles that we can see around the figure. And that's going to leave us with 59. Alright, so that's angle D, and then if I want angle C, I can just do 180 minus 59, which is going to give us 121. And then we should have every single one of those lettered angles labeled.